Today I'm going to do a review of lessons 1, 2, 3, and 5. Lesson 4 we're not doing because it's not in the curriculum, but scientific notation. You actually did that last year in grade 9 anyways. So let's start off by reviewing our exponent laws from grade 9. So I'm just going to do briefly what the exponent laws are. So at first we have our product laws. So as long as I have the same two bases, I can add my exponents. Quotient law, again, if I have the same bases, you can subtract those exponents. And then product law, so that's really important, is when we have to have that bracket in between, so then I can multiply my exponents. For all of these, what's super important to remember is you have to have the same base. The other thing I hope we drilled into your heads already is when in doubt, expand it out. So the next big thing that we talked about last week, or the week before spring break anyways, was negative exponents. Negative exponents are something that you don't ever want to leave as your final answer. We always want to leave our answers with a positive exponent. It's kind of like when we were in middle school, you always want to leave your fraction reduced or mixed instead of improper. So the general formula for a negative exponent, you kind of have two options. So if it's in a numerator or just a whole number, you move it to the denominator. Or if it's already in your denominator, you then move it to your numerator. So basically, to make it positive, you reciprocate it. Reciprocate the term. That's really important. The last thing we talked about are rational exponents, or fractions exponents. Now these seem scary. They're not too bad. We're going to get into them more and more later on, especially in our next unit. But overall, if I have a fraction, m over n, that's going to be equal to the nth root of a to the power of m. You also, for that matter, could say it's the nth root of a, then that answer to the power of m. Personal preference for what you want to do. The big thing to remember, the m is your exponent. The n, or your denominator, is going to be your root. I'm going to do two questions now that I had a few questions on last week and I never got to cover them. So the first one is on page 83. So this was lesson 3, 11C. I'm just going to take a second and write down the question here. Okay, so on this, first off, sorry, it was page 82. On questions like this, there's a lot of ways to approach them. You first, if you would like, you could distribute this -2 through and then deal with the negative, or you could deal with the negative first. On this one in particular, I'm going to deal with the negative first. Again, total personal preference. So my second term here, this 3 means it's going to stay in my numerator. So I'm going to start off by multiplying that 3 in, or applying that 3 exponent into that one. So -2 cubed gives me -8. 2 times 3 gives me x to the power of 6. -8 times 3 gives me -24. 12 times 3 gives me z to the power of 36. So now with that negative 2, I'm going to move it to the denominator. I'm not going to put it in this step. By all means, you could if you want, but I just want you to see this. So then I get all of this is being squared. So from this line, let's deal with that square. So I'll rewrite my numerator. Negative 2 squared is going to give me a positive 4. 5 times 2 is 10. 3 times 2 is 6. 8 times 2 is 16. Now, you can think about this. You can do these a lot of ways. I really want to stress that too. There's a lot of different ways you can approach this. Let's go through this term by term. First off, negative 8 divided by 4 gives me in the end negative 2. Let's look at my x's. So if I have 6 x's on top and 10 x's on the bottom, when I go to cancel those out, I'm going to be left with 4 x's on the denominator. You could have thought of that as well as 6 minus 10 gives me negative 4. Then I would move that down. On the next one, I have y to the power of negative 24. Well, that negative 24, I'm going to have to move that piece, that term, to my denominator. So now I'm going to have 24 y's and 6 y's down there, which now is going to give me a total. So y to the power of 30. So that step, I had y to the 24 and y to the 6, so I added those two to get y to the 30. My next one, if I look at my z's, 36 z's up top, 16 z's below, 36 minus 16 gives me 20 with more in my numerator. And then that is your final answer. The next question I want to go through is from lesson 5. Just going to write that over here to the side. So lesson 5, number 11 and 12, I want to go over. So this one's actually multiple choice. I'm not going to approach it that way. We'll just solve this one. So it's 9 over 16 all to the power of negative 0.5. Again, we can do these ones in a lot of ways. The first way you could think of this is 9 to the power of negative 0.5 over 16 to the power of negative 0.5, which then I have to flip both of them to get those negatives to become positive. So 16 over 0.5, then 9 over 0.5. 0.5, written as a fraction, is 1/2, and 9 to 1/2. I showed a lot of steps on this one. Quite frankly, you could have gone from this very first line all the way to the last line in one step. That would have been fine for you to do that. Anything to the power 1/2, I'm now doing that 2 is my root, so I get the square root of 16 to the power of 1. Do I need to include that 1? No. But I just want you guys to recognize that. So the square root of 16 is 4, square root of 9 is 3. So 4/3 is your final answer. The last question I'm going to do is number 12. So in this one, I have negative 1/4 all to the power of negative 1.5. Okay, so in this question, I'm going to go through it a little bit quicker to show you how I could do this in less steps than I did the previous question. So this negative exponent doesn't get rid of the negative in my term or in the base. It only gets rid of the negative when I reciprocate it. So when I reciprocate this one, I can go straight to negative 4 over 1 to the power 1/2. Did I have to write over 1? No. But sometimes it's nice to do that extra prompt. 1.5, written as a fraction, is 3 over 2. So what this means, I'm taking the square root of negative 4. That whole thing is to the power of 3. Just want to make that look a little better. Can I take the square root of a negative? No. So this answer does not exist. So therefore, we say it does not exist. Or if you would like, you could write DNE. I hope that helps kind of summarize our last couple lessons. Feel free to send me some emails and ask any questions you need. I hope all is going well.